Okay. So with respect to scalability, so Anylogic can, in my experience, Anylogic handles things pretty well up to the hundreds of thousands, up to and including hundreds of thousands of agents. When you start getting to millions of agents, I find things getting very slow. So we have run models with 1 million agents in it, but it tends to be slow, and you tend to have to really attend to performance challenges in the sense of the needs there force you to kind of think about how you do things in the model to be more economical, and you will often run your model in what we in computer science call a headless fashion, which sounds strange, but what I mean is you don't display what's shown live with 1 million, or else it will really slow it down. But I've contributed papers where I've also shown that, and this is a very common technique among agent-based modelers, that if you want to simulate a large population, you can often have rigorously identified results from smaller populations that you can then scale up. And certainly at a practical level, in other words, you can figure out how they would scale for the full population. But at a practical level, what you end up doing, in my experience, is you experiment with runs on small populations, and then you'll sometimes run it on a large population, say overnight, or for a day.
Yeah, I'm interested also in, like, we've seen models with maybe 3 states.
Yeah.
What if I want to represent a network with 100 states?
No problem. And some of the models I've given you, will be quite sophisticated in terms of the states depicted. And one of the questions I'll often get from people who are new to Anylogic and coming from other platforms, especially those when they've rolled their own platform or where they're using Repast, which is a platform that's very, very programming heavy. They tend to look at Anylogic and be quite suspicious because they say, oh, it's nice and visual, but surely that doesn't scale. Surely that's just toy type models that you can depict like this. And surely you got to buckle down and write the Java code when you want a real model. And I will stand before you, having worked on probably now in the low hundreds of models, and I will tell you that's nonsense. It works really well, actually. And it's to Anylogic's great credit that it does scale very well. So, I mean, if you look at this Beifong-Ren model, which is this tripartite model I presented 2 days ago, or if you look at, I had some student models in here, and I'm gonna, I can't remember for sure if I provided them as part of the components, because some of them are encumbered by by collaborative connections. But if we go here to student models, and this is a model which was built in 1 semester by students in one of my classes, and has since been elaborated greatly. But this is a model of deer behavior. You saw a glimpse of it at one point, and you can see that it's fairly articulated with hierarchical states, a variety of types of processes, and state charts. There's a lot going on here, and it leads to corresponding model behavior that is very, very sophisticated. So this is a model that includes mobility and transmission of infection and movement in landscapes, etc. And oh wow, that's really interesting. There's okay, let's do seasonal movement and social groupings. So this is a model which is quite, it's no wonder it's going super fast. You just can't see it. But these deer are moving over the landscape, and they have these quite strong, quite sophisticated behaviors. And my experience has been it tends to work very well for scaling to large numbers of behaviors. The state charts turn into something underneath the covers, so to speak. They turn into something that's quite efficient, and there's no problem logically characterizing a variety of types of processes using the Anylogic mechanisms. So in terms of kind of complexity, I would say actually Anylogic's a real asset in the sense that it can allow you to weave together in the same model, like system dynamics components having to do with continuous variation within the same model where you have state charts. And the state charts can get much more sophisticated than anything we've seen thus far. There's things like hidden states and history states, excuse me, and things like composite states, which really simplify description of certain complex state transitions. So it tends to be quite good in that regard, and the ability to weave in discrete event modeling and system dynamics modeling, stocks and flows, is very powerful for sort of enlarging what you can do. I will warn you though, take it from an old man, that if you have agents which have system dynamics within them, so they have stocks and flows, that's a fairly heavyweight thing. It involves running numerical integration routines to kind of simulate out how the stocks behave. And those models tend not to scale nearly as well in terms of numbers of agents. In other words, if you go into the 500,000 agent range, I think that would slow to a crawl. So that would be something to be kind of cautious about mixing system dynamics models in agents if you want, if having great scalability is very important to you. But if you're interested in scalability issues, we've run experiments I could share with you scaling results. And the scaling is fairly favorable. We've done things like successfully double the population size and see how Anylogic's performance grows and that sort of thing. And we've done so for Repast, for ModGen, and other popular frameworks. So I'd be glad to share those with you if you were interested. What I will tell you is this. When it comes to scalability, I try to make this point to my students in my classes, including my software engineering classes. A lot of people focus on the shallow issue of scalability and performance. And they say, okay, here's a platform that's written in Java. Here's a platform that's written, as we say, close to the metal in C++. And surely that's going to be faster than, say, Anylogic. Well, the fact is that it's a system. It's a complex system building up a model. And what I mean by that is there's trade-offs associated with the dynamics of model building that are not obvious. But often the systems like the high-performance version of Repast that are high performance, they require you to do a lot more work in model building. And that takes time. And that time is taken away from certain things. It's taken away in some cases from experimentation and insight with the model, but it's also taken away from the opportunities to kind of do sensitivity analysis of the model as a whole and simplify it. It makes it much more rigid, the model. In a platform like Anylogic, it's genuinely pretty flexible in terms of what you can incorporate and what you can throw out at different times. And I would say that, while you could look at really high performance frameworks, sometimes you'd be so limiting your flexibility that you end up the gain from the extra performance is a lot less than you think, because if you'd done it with a flexible tool, you would have realized, we can take out this portion of the model or replace it with an aggregate version, a system dynamics version that's aggregate or what have you. And you have a model that's much more responsive to your needs and sort of faster because you've been able to iterate more quickly in this more visual and more integrated framework that brings together the multiple types of modeling. And so what I'm saying is sometimes we fool ourselves into thinking, this has got to be higher performance, and we do a lot more work because of it, and we don't realize that work had an opportunity cost. It actually prevented us from getting as far in the modeling or from having the insights that could have simplified our original model to the point it would have been just as fast but also more responsive. So when you think about model building, you have to think and use systems thinking and realizing that there are trade-offs, and time put into one thing is time away from being put into another thing, and you need to take that into account in kind of your planning. I will say that Anylogic, probably developing a model in Anylogic is several times faster than developing a model in other platforms, just because it permits such a quick, easy addition of things and taking things out as well, compared to writing lots of code. And that time secures benefits because it can be invested in insight and it can be invested in model simplification. So it's part of a system, and you have to be cautious about just viewing first order effects in terms of performance as gating which direction you go in terms of your modeling platform. Is that helpful, those comments? Okay, the other question though was about analytics. This is great, and I can't think of a more important thing that I can do in these days than to address student questions, because these reflect your interests, your concerns, your challenges, and these are things that I wouldn't know otherwise. So I'm going to take just a few minutes to talk a little bit about analytics and Anylogic.